Okay, now, I'm going to solve these two equations. One's an exponential and one's a log. So if I've got 12 minus 4 to the 3x minus 5 equals 5, or 9 equals 9, what would you do first there if you're going to solve that equation? Subtract the 12, right? All right, so let's move the 12. All right, so 9 minus 12 would be negative 3, right? Okay, now here's the deal. I don't want to convert this to a log just yet. Do you guys see how there's a negative on both sides, like a negative in front of the 4 and a negative in front of the 3? What I'm going to do is I'm going to write it. You don't have to write it on your paper if you don't want to, but I'm going to divide both sides by -1. That literally is just going to cancel that negative on both sides. Okay, now I get people and they're like, oh, let's divide by 4. Don't do that, okay? The only way to get rid of that exponent where the variable's at, we got to convert this to a log just real quick. And this is not going to have a nice answer, I don't think, so you're going to want to grab your calculator if you don't have it out. All right, now your base of your exponent, that's going to be the 4. I'm going to swing that to the other side. When I do that, it drags that exponent just down on the level with the rest of the question. And then we get log. The base of the log is whatever that exponent was. So that would be 4. And then the 3 is just going to stay right where it's at. The whole purpose of converting it to a log is to bring that lovely exponent down on the level with the rest of the question. Okay, now, normally we can't do base 4 in the calculator, but we did that change of base, if you remember. So I'm going to change it to base 10 so I can do it in the calculator. Everything I'm going to do on the calculator screen for the rest of this problem. All right, so change it to base 10. I'm just going to write a plain log that's assumed to be base 10. You do the log of whatever you were taking the log of, so 3 for this problem, divided by the log of the subscript. And it's 2 separate logs. That's just going to give me the value and a change of base doing base 10. So we're going to do log 3. We're going to make sure we close our parentheses because whatever calculator you have is going to pop up parentheses. And then I'm going to divide that by the log of 4. Don't think you're doing anything wrong because it's going to be a weird number. And what that means is 4 to that power equals 3. It's a weird number for most of the questions on this. Now, from there, right, I had my exponent was 3x minus 5. So I'm going to keep going here. I'm going to add 5. I'm just going to do it right on the calculator screen. And then I'm going to take that, and then I'll divide that by 3. So I'm just doing it right on the calculator screen. That way we're not rounding multiple times and kind of clouding up our answer. So the questions here usually tell you to go to 3 decimal places for your answer. So this guy, I'm going to do 1.931. And this would be super easy to check if you want to plug it back into the original problem. Just remember it's a little bit off because we rounded it. Did I do it wrong?
What? No.
Oh, okay. It wouldn't surprise me if I did. Okay. Is anybody having a question? It's true though most of the time. It's true. All right, let's see what I got here. Question. Yes. Okay, I just canceled the negative out on both sides. Because if I swing that over like that, the -4 you're not allowed to have a negative base of a log, and you can't take the negative base of a number either. But if I get rid of it right there, you can cancel it out on both sides and just work with a positive. Yep, that's a really good question. That's the only reason, because you can't take the log of a negative number, and the base of your log is not allowed to be a negative number. Okay, now, this is an excellent question because I've got literally all the properties of logs in this problem. So I'm just going to write this step out just real quick. The number in front is multiplied by the log, can become an exponent on whatever you're taking the log of if you're trying to squish these together as a single log. So this is really the log of x squared minus the log of x cubed, and then plus the log of that 550. All right, after I've applied my lovely little power rule, you have to apply the rules as you read the question from left to right. So I'm just going to do this all in one step. So log, and if I don't have a subscript, my subscript is 10, right? So I might go ahead and just write that in here real quick. So if it's just the word log, it's called the common logarithm. It's assumed to be base 10. Now, what I would do first, we would have the x squared, subtraction turns into division, divided by x to the third, and then after that I have multiplication. So then it would be that whole fraction times that 550. Okay, what I'm going to write down here, that first little thing, I can simplify that. There's one more x on the bottom of that. The 550 would end up going in the top of that fraction. So this is going to be log base 10. You'd have 550 over x squared. And then on the other side is just a 3. Now, to get rid of the log, this is a reverse of what we just did in the last question. To get rid of the log, we're going to convert this to an exponential. So the 10, going to swing across that other side there. We got 550 over x squared. Now, the 10 becomes a normal size number and pushes that 3 up in the air. And I did not leave enough space here. Sorry, guys. This would be 550 over x squared. 10 to the third power is 1,000. And probably the easiest way I could tell you to do that problem would let me just turn it into a proportion real quick. So I'm just going to write that 1,000 over 1 because my variable ended up being in the denominator there. Then I can just cross multiply real quick. So I'd have 1,000 x squared equals 550. And then I'm going to do 550, divide by 1,000, which is 0.55. And we're going to take the square root of that. Now, I'm not going to put a plus and minus because I'm introducing the square root to solve that. I'm not going to put the plus and minus because both of those first terms in that original just have a log of x, so we can't plug in a negative number. So it's just going to be a positive version. So I'm just going to do square root 0.55. And so about 3 decimal places, 742. So just a little review of what we were working on a little bit last week. Is anybody, question?
How do you get x squared?
So if I'm here, x squared over x to the third, you have one more x in the bottom. So I'm basically canceling, and I did that whole problem wrong, didn't I? Okay. Forgive, this should have just been x. Oh my gosh. I'm sorry, guys. This should have just been x. So then, no one stopped me. I kept going. Just should have been x. Sorry, I have one more x in the bottom. Jeez, fired. Okay, so it should just be 550 divided by 1,000. Okay, my fault. Which should be 0.55. Why did I just type that in my calculator? Okay, forgive. Hey, you never know. Okay. My fault. Sorry, guys. That should have been x. No one stopped me. I just got going. There's one more x in the bottom, not 2 more x's in the bottom. Okay. I apologize. Does anybody have a question? Okay. Now, we're going to try not to screw anything else up today. Okay, now, we're going to talk about e today, which is literally, it's like pi. It's an irrational number that has no pattern to it. It can't be written as it can't be written as a fraction. If you guys, and this is on regular and scientific calculators, if you guys have a graphing calculator, it's the button, it's like right next to the 4, there's an e to the x. If you guys have a scientific calculator, look for your button that it'll say ln on it, and that e to the x will probably be a second function on the scientific calculator too. I just don't have one up here to show it to you. But e is a number like pi, irrational, no pattern to the decimal. It goes on forever. If I were to actually, here I'm just going to do e to the first to show you guys on the calculator here. It just continues. It looks like there's a pattern to that decimal, but there's actually not. And this is used in continuous growth or decay. It's used in a lot of banking stuff. We're going to get into that more tomorrow and Wednesday, but today we're just going to work on, like, can you tell me what this is in the calculator? So these first couple questions we're just going to practice, make sure everybody knows where this button's at. We're just going to do e to each of these powers. So e is a number, it is not a variable. Like I said, it's like pi. So see if you can find that e button. We're going to do e to the third, e to the negative fourth, and we're going to do e to the 1/2 power. And I'm just doing them all right on my calculator screen right now. I'm going to jot them down for you here real quick, but I'll come and if you need help locating that on your calculator, I will come in 1 second and help you. I'm just going to jot these down. Remember, negative exponent would just be 1 over e to the 4th, so it should not be a negative number. It should just be a fraction or a tiny decimal, as you guys are going to see. And the 1/2 power would basically be like the square root of e. But just check those real quick. I just want to make sure everybody knows where these buttons are at. All right, is anybody having a question about where that's at? Okay, now, here is the deal. We're going to talk about natural log function. All right, so you have a log, right? Log base 10 is a common log, so we're going to do a natural log today. The natural log is a log with e as its base, and this is used frequently. This will be, you guys would see this in science, you would see this, like I said, in banking. So they give it its own button on the calculator. So all of these questions today, you can actually evaluate them on your calculator. But it looks like an I, but it's actually a lowercase l and an n. And I, in my mind, call it log naturel, but I think that's probably wrong. But it's the natural log, but I don't know why it's ln instead of just nl, but whatever. So the natural log is just a log base e. And the natural log follows all properties. So like if we see addition between two things, it turns into multiplication. If we see a number out in front, it's an exponent. Follows all properties of just normal logs. Because it is a log, it's just a log base e. It has its own special button on the calculator. So we're just going to review properties here real quick, just to write these as a single log. So instead of log, you're going to see the ln, but the properties work exactly the same. So if you see a number out in front, that can become an exponent on whatever follows. So this would be natural log 12 squared minus natural log of 9. So natural log 12 squared is 144. And then, do you guys remember, if I have subtraction between two logs, even though these are natural logs, we're going to put that together, just one natural log out in front. This is different than the change of base. And then to write this as a single natural log, you'd have the 144 over 9. And I think, give me 1 sec, I think that's actually a nice number. It is. All right, so this could just be natural log of 16 as a single log. Just natural log instead of a log is the only difference. The properties are the same. So like if I see a 3 out in front here, this is natural log of x cubed plus natural log of y. If I want to squish those together, it's just a single natural log. What would you guys write after the natural log for that one? X cubed y. Done. You multiply them together, and that would be my answer. Let me try. This one has numbers to kind of simplify a little bit. So number out in front is an exponent. So this would be 2 to the 5th. Natural log of 3 minus natural log of 4. Now, the 2 to the 5th is just 32. Now, if I would multiply the first two, right, as you read them from left to right, that's how you want to apply the properties. So I'm going to do 32 plus in between 2 is going to turn into multiplication. So it would be 32 times 3, and then I have minus the natural log of 4, so then I would divide that by 4. So I'm going to, thank you. I'm just going to do 32 times 3, and then I'm going to divide that by 4. So all simplified here, this would be natural log of 24. Is anybody having a question? Okay. Okay. Now, we're going to solve some equations. Okay, now here's what you have to remember. The log, if you see the ln, the natural log, log natural, whatever you want to call it, these most of the time are not going to have nice answers. The base is e. So I like to write that in if I'm solving an equation because I like to have something to swing to the other side. You are literally just going to do this on your calculator. So to cancel out a log or a natural log, we're just going to convert this to an exponential real quick. And just remember, e is not a variable, it's just a button on your calculator. So this would be 3x, and then the e, that base, is going to come and be a normal size letter, and it's going to push the 7 up in the air. And what we're going to do on our calculator is e to the 7th power. So wherever your e button was at, we're just going to do e to the 7th, hit equals, and then to actually answer the question there, I got to divide that by 3. And we're going to go 3 decimal places on these, and most of them are not going to be nice numbers. So this is 365.544. These are easy to check because you actually have a natural log button on your calculator. So if you want to find that, if you have a graphing calculator, it's right next to the 4. If you have the E button, it's probably just the non-second function on that. It's probably just that. So if I want to do 3 times that 365.544, I rounded it, so it's a little bit off, but it should be really, really close to 7. So these are easy to plug back in and check because you do have a natural log button on your calculator. Okay, now, couple options here. If this is me, what I would tell you to do, if you have a number out in front, right, that can become an exponent on whatever you're doing. However, I would not put that exponent on here. What I would actually do in this situation, I would divide by 5 just to get it away, because it basically, otherwise I'm going to have to take a 5th root. This will be a little bit faster. So if you have something out in front like that, I actually want to encourage you to divide. So this would be the natural log of 2x equals -3. And then it's super similar to the problem we just did. If you don't see the base, like I like to write the e in, the natural log has base e. We're just going to swoosh that to the other side. Then you get the 2x e to the -3rd, which will be some gross number. So I'm just going to do the rest of this on my calculator screen. So I would just do e to the -3rd, hit equals, and then I'm just going to divide that by 2. And that should be my answer. So 0.25 to the nearest thousandth. It's just 3 decimal places. And again, if you want to plug these back in to check, you could do that super quick. All right, very similar to that problem we just did. What I would tell you to do here, if you can remember this, I'm actually going to undo the power rule real quick and pull that 3 down in front of the natural log. So this is the same as 3 times the natural log of this 2x minus 4. Now, the reason I'm doing that is because that will avoid me having to take a cube root at the end of the problem. It'll be easier to do on the calculator. To get rid of the 3, I'm just going to divide both sides by 3. And so we'd have natural log 2x minus 4. 6 divided by 3 is just 2. And then don't forget, if you have a natural log, they don't write it in there. It has a base of e. So to get rid of the natural log, I'll just convert this to an exponential super quick. And then I'm just going to do the rest of this problem on my calculator. So 2x minus 4. E, the base of the log, becomes the base of your exponent, so it's going to push that 2 up in the air. It's not a variable, it is a number. And so we're just going to do e squared. Okay, now for this one, we'd have to do 2 steps, right? Because my exponent was 2x minus 4. What would you do first after you squared the e? Add the 4. We're just going to do this, like undo our order of operations. So just right on the calculator screen, I'm just going to put plus 4, and then you would divide by 2. So just right on the calculator screen. That way I'm not rounding multiple times as I do the problem, because the more you round, the more inaccurate your answer is going to be. All right, so for this guy, let's see, 5.695 to 3 decimal places. Is anyone having a question? Okay, now, these guys are exponential equations. Okay, so I'm going to do this for this first problem only, but you don't have to. So you want to get whatever you're taking to the exponent. This is 5e to the x. The only thing that's being taken to the exponent is e. So not the 5. So I'm going to get rid of the 5. So this is going to say e to the x equals 11. Now, to get rid of my variable being in the exponent, I'm going to convert this to a log. I'm going to do this on this problem only. Okay, I'm going to swing this over here. The base of the exponent becomes the base of the log. So that would be log base e of 11. Now, normally I don't do that in a problem because I know the log base e is the natural log. And so literally all you have to do on your calculator, just instead of the log button, it's probably right near it. If you have a graphing calculator, it's right next to the 4, just that ln button and type in 11 and you're done. So my answer here, this would be 2.398. This would be another example, be super easy to check. Do 5 and then the E button to that power, 2.398. And it'll be a little bit off because we rounded it, but it should be pretty close to 55. Does anybody have a question? You just want to isolate whatever you're taking to the exponent and then convert it to a log. If you're dealing with e as your base, we're just going to use a natural log. So like for this guy, I'm going to add 8. So I got 4e to the 3x equals 2. We're going to not forget to divide by the 4. So I have e to the 3x. 2 over 4 is just a half. If it's me, I'm going to type 0.5 in my calculator, so I'm just going to write 0.5 there real quick. Now, just remember, when you swing the e to the other side, it's the base of a log. So the 3x comes down on the level with the rest of the question. Okay, maybe I'll write it again here. This would be log base e of a half, but the log base e is just the natural log. I'll have to do one more step on this question. So I'm going to have to hit my natural log button, hit the 0.5, figure out what that is. It'll probably be some tiny decimal. And then we're going to divide that by 3 because our exponent was 3x. We're just doing it all right on the calculator screen, so we're not rounding multiple times. So this is about negative 0.231 to the nearest thousand. Okay. And I'm going to do one more. We're not going to do the word problem at the bottom of the page because I don't have anything like that on the homework. Okay, I'm going to move that 7.2. So, I don't know. It must have just felt like using a decimal for an unknown reason in this problem. So that's actually going to end up being 2. So it's a nice number. When you swing the e down to the other side, we're going to convert this to a log. The log base e is the natural log. Log base e is just a natural log. So the e goes to the other side. We get rid of the e, we get an ln. If you got an ln, you're going to get rid of it with e. So this one, you're going to do 2 things to this one. So I'm going to do natural log of 2. Now, what should I do after I do my natural log of 2? Yes, multiply. So you get the 5 out of the denominator. So I'm going to do multiply by 5. And so then I would have 8x equals this mess on my calculator screen. So then after I multiply by 5, I'm going to divide by 8. And so my answer for this last one is 0.433. And again, this would be super easy to check because you have an E button on your calculator and you have a natural log button on your calculator for all of these questions.